In this video we will see rotational motion. So here if you see, this is O point about which this particular rod is rotating, and A point comes to A dash point and B point comes to B dash point, because it is rotating with angular acceleration alpha and angular velocity omega in this direction. So now, one more thing, RA is a distance from O to A, which is similar to O to A dash, and RB will be the distance from O to B. Now first case is moving with constant angular acceleration, so angular acceleration will not change and body is moving. So first equation we use is omega, which is final angular velocity at this point, at this particular rod, and omega naught is at AB, means at this particular position of this rod. So now due to alpha, this omega naught will comes to omega at this particular position. So omega final will be equal to omega initial, omega naught plus alpha into t. So this particular rod is having angular velocity of omega naught, and after time t it comes to this position where its omega will be the angular velocity, and theta is the angle traveled from this position to this position. So we have to calculate as omega naught t plus alpha half into alpha t square, and omega square minus omega naught square will be equal to 2 alpha t if we want relation with this variable and eliminate time from the equation. So these three equations we can use. These are the equation which we used in rectilinear motion, but the variables were u, a and s. So we simply have to replace this variable with the new variables, and same we are getting for constant acceleration. Here the acceleration will be angular acceleration. And if you see here, this omega of A point and B point will be same. Omega A will be equal to omega B. Theta at a particular angle will be equal to theta B, and alpha at A will be equal to alpha B. So it is irrespective of the position on the rod. So alpha will be same for all the points on the rod, and particular angular velocity, let's say omega naught. So here all the points on this rod will have omega naught. At this particular position all the points will be having angular velocity omega. So it is irrespective of the position on the rod. So similarly the theta between these two point, A dash and A point and B dash and B point, will be same. Now the distance traveled from A point to A position will be SA will be equal to RA into theta. So RA is a distance, radial distance, and theta is an angle. So this will be the distance traveled from A to A dash. Velocity at point A will be RA into omega. So omega RA into omega at velocity at A dash will be omega naught, and velocity at A dash will be equal to RA into omega, final omega. Similarly acceleration at point A will be RA into alpha. The same acceleration will be at A dash also, because it is constant angular acceleration motion. So this is a tangential acceleration in this direction, in tangent direction to this arc A to A dash. So normal acceleration at point A will be RA into omega square. So normal acceleration will be pointing towards the center, means from A to 0. It is direction will be from A to 0 in this direction, and total acceleration will be under root of AT square plus AN square. Now if we see other kind of motion will be continuous motion, where omega we have to find by differentiating theta, because theta, omega and alpha all three will be the function of time. So here it is a continuous motion where omega, alpha and theta all are changing with time. So omega will be d theta by dt, alpha angular acceleration will be d omega by dt, and alpha we can write as, here if we multiply in this equation d theta up numerator and denominator, then this d theta by dt will be equal to omega, and d omega by d theta remains as it is. So alpha will be found by two methods. So this is a continuous motion, and this motion was, first motion was constant angular acceleration. So this is how we can solve any numerical which involves rotational motion with some basic equations, and these questions are often asked in examination. And thank you for watching this video, and see you in the next video.